Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to solve quadratic equations by using the square root method and completing the square. So let's get right to it. There are several ways to solve a quadratic equation or function, such as y equals ax squared plus bx plus c, or in function notation, f of x equals ax squared plus bx plus c, which include square root method, completing the square, using the quadratic formula, factoring, which we've already talked about, and you should know that's when you factor a trinomial or a binomial into two factors, and you set each of those factors equal to 0, and you solve for the variable. That's called the zero product property. And last but not least, by graphing. So let's talk about what we're going to learn today. First thing we're going to talk about is the square root method. In order to solve quadratic functions or equations using the square root method, the function must be in the form of y equals ax squared plus c. Please notice that since there is no bx value, because b equals 0, so there's no b value there. So that's why we're left with ax squared plus c, okay? When the function is in the above form of y equals ax squared plus c, simply set y equal to 0 and solve for x. Your solutions are the x-intercepts or real zeros or the roots of the function. All of those vocabulary words should resonate with you. Okay, so let's get right to it. We're going to go ahead and solve each quadratic function. They are in ax squared plus c form. So we're going to start by setting y equal to 0 and isolating the x. So I'm going to go ahead and add 64 to both sides. And I can solve for x here by eliminating that power of 2. Please remember that you can square root a value that is being squared in order to eliminate that power of 2. So x will now equal plus or minus 8. Please remember that when you use square root to solve equations, you must use both the positive and negative side. Next, we're going to set y equal to 0, and we're going to once again solve for x. So I'm going to add 27 to both sides. And then we're going to go ahead and solve for x here by isolating the x squared first, dividing 3 to both sides. That's going to give me x squared equals 9. I'm going to eliminate the power of 2 by square rooting both sides, and x will equal plus or minus 3. And there you have it. Okay, now sometimes you have a binomial that's being squared or a multi-term polynomial that's being squared. You eliminate that power of 2 the same way. We're going to go ahead and square root both sides because the square root and the power of 2 cancel, leaving me with x minus 2 equals plus or minus 5. I'm going to add 2 to both sides, and please remember here that x equals 5 plus 2, positive 5 plus 2, and negative 5 plus 2. So x will equal 7 and negative 3. And last but not least, we're going to go ahead and set y equal to 0 here. X squared plus 81, we're going to subtract 81 to both sides. And negative 81 equals x squared. We're going to go ahead and square root both sides to eliminate the power of 2. And we've got that x equals the square root of negative 81. Wait, you may be saying, hey, that can't happen. That's no solution. Well, it was no solution in the past, but now we're going to introduce something called imaginary numbers. And an imaginary number, symbolized with the lowercase letter I, equals the square root of negative 1. And I squared equals negative 1. I cubed equals negative I, and I to the fourth power equals 1. So this is very important to learn. I is an imaginary number, and it stands for the square root of negative 1. So I've got here square root of negative 81, which can be broken down into negative 1 times 81. The square root of negative 1 is I, so x will equal plus or minus 9I. And there you have it. So no longer will you have to put no solution if you have a square root that has a negative value inside of it, for you can take out that negative 1 as an I. Okay, completing the square. Completing the square allows you to transform unfactorable trinomials into factorable perfect square trinomials. How does it work? You make a perfect square trinomial from x squared plus bx by adding b over 2 squared. It's that simple. Because when you add b over 2 squared to an x squared plus bx binomial and you factor it, you're going to take the square root of the first term, which square root of x squared is x, and then you're going to go ahead and combine it with the square root of the last term, which the square root of b over 2 squared is b over 2. Whether or not it's plus or minus depends on whether or not b over 2 is positive or negative. Now, before we learn how to solve a quadratic equation by completing the square, let's practice the simple act of just completing a square. Step 1, we're going to go ahead and identify the b. So in this particular case, b equals negative 10. Step 2, we're going to find b over 2 squared. So b over 2 squared would equal negative 10 over 2, which equals negative 5. And we're going to square it, and we're going to leave it like that in that form. Because we're going to add the value of b over 2 squared to complete the square. So we have the x squared minus 10x, and now we're going to add the b over 2 squared, which is negative 5 squared. Leave it in that form because now our last step, we rewrite it as a square of a binomial. And the easiest way to figure that out is taking the square root of the first term, which is square root of x squared is x, and combining it with the square root of the last term. The square root of negative 5 squared is negative 5. And then we square that binomial, and boom, you're done. You just completed a square. All right, so let's practice that skill first. So let's complete the square for each. Well, my b here is 6. So b over 2 is 6 over 2, which is 3. And we're going to square it. Because remember, we're looking for b over 2 squared. And then we're going to add it. So we got x squared plus 6x plus my b over 2 squared, which is 3 squared. And now we're going to take the square root of the first term, which is x. And we're going to combine it with the square root of the last term, which is 3. And we're going to square that binomial. Next, the b in this particular case is negative 32. So let's calculate the b over 2 squared. We've got negative 32 over 2, which equals negative 16 squared. So now we're going to add that b over 2 squared to the x squared minus 32x. So we add the negative 16 squared, and now we factor. Square root of the first term, square root of x squared is x. Square root of the last term, square root of negative 16 squared is negative 16. And we square that binomial. It's that simple. And last but not least, let's check it out when it's a fraction, when it's not perfect and beautiful. The b in this case is negative 5. So I want to calculate my b over 2 squared. So I've got negative 5 over 2 squared. That doesn't simplify, so we're going to leave it just like that. So I've got x squared minus 5x plus my b over 2 squared, which is negative 5 halves squared. And now, square root of the first term is x, and square root of the last term is negative 5 halves. And we square that binomial. And there you have it. That's how you complete a square. Now, let's learn how to use that skill to solve a quadratic equation by completing the square. Okay, so step one, we're going to go ahead and isolate the ax squared plus bx and divide a to both sides unless a equals 1. If a equals 1, we don't have to divide anything. So I'm going to first subtract 6 to both sides to isolate my 3x squared minus 12x. That equals negative 6. Now I'm going to divide by a, which in this particular example is 3, leaving me with x squared minus 4x equals negative 2. Now I'm going to complete the square. So my b in this particular case is negative 4. My b over 2 squared would equal negative 4 over 2 squared, which would equal negative 2 squared. So now I'm going to go ahead and add my b over 2 squared, which is negative 2 squared, to both sides. Now I factor, so the square root of the first term is x, square root of the last term is negative 2, square that binomial, and then I've got negative 2 plus negative 2 squared, so that's negative 2 plus 4, which equals 2. Now we use the square root method. We cancel out the power of 2 by square rooting both sides. I've got x minus 2 equals plus or minus square root of 2. You add 2 to both sides, and x equals plus or minus square root of 2 plus 2. Or you could write it as x equals square root of 2 plus 2, comma, negative square root of 2 plus 2. And there you have it. That's how you use completing the square to solve an unfactorable trinomial. All right, let's get to it. Let's solve each equation. Let's use completing the square. We're going to set y equal to 0, first of all. Got x squared plus 3x minus 6. Next step, we're going to go ahead and isolate the x squared and the bx. So I've got 6 equals x squared plus 3x. My b in this particular case is 3. My b over 2 squared in this particular case is 3 over 2 squared, which I'm going to add to both sides. I'm going to add my b over 2 squared to both sides. It's going to give me 9/4 plus 6 over 1 equals square root of the first term is x, square root of the last term is 3/2. I'm going to square that binomial. That's going to give me 9/4 plus 6 over 1. The 1 goes to 4. The 6 goes to 24. So I'm going to have x plus 3 over 2 squared equals 33/4. I'm going to go ahead and square root both sides to eliminate that power of 2. So I've got x plus 3/2 equals plus or minus square root of 33 over 2, because the square root of 4 is 2. And I'm going to subtract my 3/2 to both sides, and x will equal plus or minus square root of 33 over 2 minus 3/2. And there you have it. Let's go. Not that bad. Very step intensive, but once you've got down the steps, it's pretty simple. Number 2, we're going to isolate the x squared and the bx. So I'm going to go ahead and subtract 4 to both sides, leaving me with x squared minus 4x equals 96. Now I'm going to go ahead and complete the square. My b in this case is negative 4. My b over 2 squared in this case is negative 4 over 2 squared, which will equal negative 2 squared. So I'm going to add my b over 2 squared to both sides. So I'm adding that negative 2 squared to both sides. And then I'm going to factor. So the square root of x squared is x. The square root of negative 2 squared is negative 2. Square that binomial, complete the square. And then 96 plus negative 2 squared, that's 96 plus 4 equals 100. I'm going to go ahead and cancel out that power of 2 by square rooting both sides. Eliminating the power of 2, I've got x minus 2 equals plus or minus 10. Going to go ahead and add 2 to both sides to isolate and solve for x. So x will equal that positive 10 plus 2, which is 12, and that negative 10 plus 2, which is negative 8. And those are my solutions. All right, last but not least, let's go ahead and shrink this down here a little bit so we can have some more space. All right, perfect. So first things first is isolate the ax squared and bx. So I'm going to go ahead and add 2 to both sides. I've got 9x squared minus 12x equals 2. I'm going to go ahead and divide by 9 since it's not 1 this time, leaving me with x squared minus 4/3 x equals 2/9. Now, my b in this case is negative 4/3. My b over 2, please pay attention to this. This is b over 2. Remember that the 2 here has an invisible 1. That's 2 over 1. So we're going to stay, change, flip. So we're going to stay, change, and flip. So my b over 2 here is really negative 2/3, and that's what we're going to square. Because remember, we always need b over 2 squared. So now I'm going to add my b over 2 squared to both sides. I've got x squared minus 4/3 x plus, I'm going to add my negative 2/3 squared to both sides, my b over 2 squared. I've got 2/9 plus the b over 2 squared, which is 2/3 squared in this case. Please be real careful to note this whole process of the state change flip when you have a fraction as b. It's going to make your life a lot easier. So now the square root of x squared is x. The square root of negative 2/3 squared is negative 2/3. We're going to square that binomial, completing the square. And that's going to equal 2/9 plus 4/9. So I've got x minus 2/3 equals 6/9 actually, because 2/9 plus 4/9 is 6/9. And I'm going to go ahead and cancel out that power of 2 by square rooting both sides, giving me x minus 2/3 equals plus or minus the square root of 6 over 3, because the square root of 9 is 3. And I add 2/3 to both sides, and x equals plus or minus square root of 6 over 3 plus 2/3. And there you have it. Bam, we're done. That's how you solve quadratic equations that are not factorable by completing the square. All right, last skill we're going to talk about today. We're going to be applying the Pythagorean theorem. Please remember that a squared plus b squared equals c squared, where a and b are legs of the right triangle and c is the hypotenuse. Please note that the hypotenuse is always across the 90-degree angle. So how does this work? Let's find the length of the hypotenuse in a right triangle with leg lengths of 5 inches and 12 inches. Well, I've got a right triangle here, and my legs are 5 inches and 12 inches. So I'm going to use the Pythagorean theorem. The c, remember, is always across the hypotenuse. So I've got a squared plus b squared equals c squared. So I've got 25 plus 144 equals c squared. That is 169 equals c squared. I'm going to solve for c by taking the square root of both sides, eliminating the power of 2, so c equals plus or minus 13. But please note that we're dealing with a real shape, a real figure, so we can't have negatives in the real world or for side lengths, so c will only equal positive 13. And it's that simple. That's combining the Pythagorean theorem with the square root method. And now let's look at a real life example. A lighthouse located in Maine stands 162 feet tall with the observation deck located 158 feet above the ground. If a person were standing on the observation deck, he or she could see approximately 18 miles. Assuming that the radius of Earth is 3,960 miles, verify this claim. Let's please take a note that 5,280 feet equals 1 mile. And that's going to be very important in a couple seconds. First of all, they're telling us that the radius of Earth is 3,960 miles. So please remember that the radius is the length from the center of the circle to any point on the circle. So that's a radius, and that's 3,960. From the center to, once again, the base of Earth, in this case, the base of the lighthouse, is also 3,960. But they tell us that the observation deck is located 158 feet above the ground. Now, we can't work with feet and miles, so we're going to go ahead and convert feet to miles. Please remember that if we're going from a fly, which is a smaller unit, to a horse, which is a larger unit, we divide of course. So fly to horse, divide of course. Horse to fly, multiply. It's a little trick for you to remember. So we're going fly, which is 158 feet, to horse, to miles. So we're going to go ahead and use that fact that there's 5,280 feet in 1 mile. So when we convert that, 158 divided by 5,280, that gives us 0.0299, or basically 0.03 miles, 3/100ths of a mile. So now we can write that the distance from the base of the lighthouse to the observation deck is 0.03. And the claim that we're trying to prove is that from the observation deck, looking out into the horizon of Earth, we can go ahead and see for approximately 18 miles. So let's prove it. 18 can be called your A. 3,960 miles can be called your B. And 3,960 miles plus the 0.03 miles can be called your C. So let's see if this works. A squared, which is 18 squared, plus B squared, which is 3,960 squared, does that equal C squared, which is 3,960.03 squared? Let's see if this is valid. All right, let's verify this claim. So I'm going to go ahead and plug in 18 squared plus parentheses 3,960 close parentheses squared. That's going to give me 15,681,924 miles. Does that equal, let's go ahead and plug in our calculator, 3,960.03 squared? Well, that gives me 15,681,837.6 miles. That's pretty close. So they did say that you could see approximately 18 miles. So this is approximately equal. So yes, that claim is valid. Thank you so much for watching. I hope you learned a lot, and come back anytime now. Take care now. Bye-bye.